Hey everybody, I wanted to spend a little bit of time talking about rate and distinguishing between average rate and instantaneous rate. And so let's get started. In chemistry, the rate of a reaction can be determined two different ways, or it can be expressed in two different ways. One is an average rate, and the other one is an instantaneous rate. The average rate of a reaction is really what it sounds like. The average rate of a reaction is kind of how fast the reaction goes at the beginning, how fast it goes at the end. You take the average of the two, and that's the average rate of the reaction. Okay, and so you can find this either by using a formula, or you can find it graphically by doing all those things that you learned in high school algebra. You can do some graphing and do some things there. Okay. Now, maybe the more interesting thing, in chemistry at least, is to find the instantaneous rate. And that is how fast the reaction is going right at this moment. And that is a little more interesting, chemically speaking, because typically as chemists we want to know how fast the reaction is going right when we're looking at it, and then we can make predictions about how much reactants, how much products there are, and things like that. Okay, and so typically we figure this out by using graphical analysis. Okay, and so what we're going to do is we're going to graph concentration versus time, find the point of interest that we're worried about. So if that's 100 seconds, we'll go up over to 100 seconds and look up, and then we'll make a tangent line to that point of interest, and then we'll find the slope of that tangent line. Okay, and so that's a calculus thing. So if you haven't done calculus, then I've just described this method. If you have taken calculus, this is basically just finding the derivative at a certain point. So let's describe a little bit more about the difference between instantaneous rate and average rate, and then I'll go into some graphical methods here to determine the two. Okay, so let's say you're in a car and we're going from Philadelphia to this small little town called Collingswood, right on the other side of the river. And so the point is that you're on the blue route. I'm really bad at actually knowing interstates that go between New Jersey and Philadelphia. Anyway, so let's say you're on the blue route and you look down. At that moment, you were going 63 miles an hour. But the thing is that that's not the average speed, that's the instantaneous speed. Okay, and so in order to find the average speed, you have to find out how fast you were traveling through the whole time, and then your average speed, because of red lights and whatever, could be 25 miles an hour. And so you can gather that these two pieces of information both have their value. Okay, if you want to know how long it's going to take the trip, you're going to use the 25 mile an hour average speed. If you want to know how fast you are going right now, you're going to use the 63 mile an hour speed. Okay, and so there's a definite difference between these two pieces of data. Okay, now here's a real life example, a second one, and so this is concentration over time. And so before we get into this, okay, let me explain what's going on here. There's a reaction that's happening, and in that reaction, I guess it's phenolphthalein here. And phenolphthalein, the concentration of phenolphthalein is decreasing following this that function. Okay, and so you can, in the lab, you can measure this at certain times and figure out what the concentration is, and you can get a graph like this. Okay, there's ways that you can get a graph right in the lab and do this. But the point is that phenolphthalein is obviously getting used up because it is because the concentration is decreasing over time. Okay, and eventually it gets to a point where the concentration is not changing. It's not that it went to 0, it's just that the concentration isn't changing, okay? So how do we figure out the average rate and the instantaneous rate? Well, if we're going to do this graphically, here, this is what we're going to do. If we're going to do this graphically, from 0 to 300 seconds, okay, the average rate of change, you draw a line, okay, a straight line, okay, and then you can find the slope of that line. Or you can do y2 minus y1 over x2 minus x1. I mean, these are all ways to determine the slope, but the point is that you can find the average rate of change, okay? The instantaneous rate of change now is determined a little differently. What we're going to do is we're going to go to 100 seconds, and we're interested in that point. And now what we're going to do is we're going to draw a tangent line. Let me make sure that I draw my tangent line well here. Okay. I have to try to erase it so that it's going to look good. Okay, so my tangent line just barely touches this in one spot. Okay, and now what I can do is I can find the slope of that tangent line, okay, in a bunch of different ways. And so that gives us the rate of reaction here, the instantaneous rate of reaction here. Okay. The other thing that comes from doing it this way is that the instantaneous rate of the reaction, without doing the math, the rate of reaction here is one thing, but if we look down here, this instantaneous rate of reaction has changed and it is now less. So the speed, the rate, decreases throughout the lifetime of the reaction until eventually the rate becomes 0, meaning the reaction isn't going any fast, isn't going anymore. Okay, we're not producing any more reactants or products. And so the instantaneous rate is different than the average rate. Okay, so again, I'm going to highlight this one more time because the whole point of this, whether you understand the graph or whatever, the whole point of this is, let me get out my big eraser here, is that if we're going to do instantaneous rate, okay, we'll do instantaneous rate at 40 seconds. Okay, that thing, the slope of that line, so this thing is going to be going fast because it's very steep. And here it's going a little slower, but it's still going pretty well. Here, this is going really slow, and so the instantaneous rate changes throughout the reaction, while the average rate does not change. The average rate is not going to change because that is measuring the average over the time. Okay, so I hope that talks a little bit about, or explains the difference between average rate and instantaneous rate, and have a great day.